Our final presentation is from longtime friend of EHP and participant in one of our community monitoring engagements, Stu Berg. Stu graduated from Rensselaer Polytechnic Institute with a Bachelor of Engineering in Electrical Engineering and a Master of Engineering in Electric Power Engineering. He worked at Florida Power and Light in information services, developing and supporting engineering computer applications, and then worked at New York State Electric and Gas in information services for 30 years, where he was responsible for engineering computer applications and later financial modeling for the company. He is now retired, but still very active, as you are about to hear. And so we will hand it off to him. You go,
Thank you.
Stu.
Thank you. Okay, first slide is up. I call them slides. Maybe I shouldn't call them that. Page one. We'll call it page one. Natural gas compressor stations are needed for moving gas from wells to users. Obviously, you have to compress it, give it more pressure to go through the pipe. Gas leakage and PM 2.5 particulates at natural gas compressor stations are major sources of local pollution. And compressor stations rely on engines, typically powered by natural gas or natural gas to compress the actual gas. So they're using their own natural gas to run these compressors. They're huge machines. During the combustion process in these engines release various pollutants, including PM 2.5 particulates. During the operation and maintenance activities, leaks can occur in pipelines and equipment. So there's lots of opportunity, maybe I shouldn't call it that, but for leaks and pollution to be released. And these leaks release unburned natural gas, which can react in the atmosphere to form PM 2.5. There have been significant pollution reduction technology changes in compressor stations in the last 75 years. The old compressors used wet seals. I don't know how much you want to get into this, but they used what are called wet seals, which produced fugitive emissions, which released fugitive emissions of methane, VOCs, and HAPs, which are pollutants known to cause or may reasonably be anticipated to cause adverse effects to human health and adverse environmental effects, according to the EPA. And now modern dry seal turbines are available, which greatly reduce those releases. Now the three operating compressor, if you look down this list, you see that we had one compressor installed in the 1950s, and then we had numbers 2 and 3 in the 1980s, and a 4 in 2010, replacing compressor 1. And compressor 1 stayed there, and they used it they couldn't even get parts from the 50s for the other two compressors. So they were having a real maintenance problem because they'd have to steal them from the first one, which was decommissioned, and then use it in 2 and 3. I mean, it was so we had that on our side that it would replacing this outdated equipment was helpful to them, which is an important factor in getting things done with gas companies. And then compressors 5 and 6 was the major project that was done most recently, with the state-of-the-art technology greatly reducing pollutants that were released to the air. And the actual construction project ran from August of 21 through January of 22. Also now the three operating compressors use exhaust stacks, which you can see one there. You see it up in the upper right, kind of just almost at the skyline there. Yeah, that's one of them. In fact, that's the one for unit 4, I believe. Yeah, and they used, and what they did in this project, which they weren't going to do, but what they did, and we were very pleased, that they added an oxidation catalyst even to the unit that was installed in 2010 to reduce VOC emissions. Nitrogen oxides can contribute. It's one of the pollutants, can contribute to smog and acid rain, but are now converted into nitrogen and oxygen by the oxidation catalyst. And you may recognize that name from similar technology as catalytic converters used in cars. So the technology is similar to that. Can we go on to page 2, please? Okay, this one shows the placement of our monitors, and the community. We had a community meeting. This all started with a community meeting that we held for this project, because and that this project was mainly because Dominion needed we got the town board, Dryden Town Board, involved, and they are the ones that had to approve this project. So the Dryden Town Board was very cooperative with us as far as making sure that all the right things were done, and not to approve, and basically not. So that's kind of like, you don't want to force maybe a company to go into this direction, but it was very helpful to have the town board, which approves the project, to on your side. Let's put it that way. We also had a representative from Mothers Out Front who attended the meeting, as I did when we had this original meeting. And the community project was, our community project was just to make sure that local pollution would be greatly reduced. It exceeded our expectations when Dominion was the company at the time that owned this plant, agreed to retrofit Compressor 4 with the oxidation catalyst, as I mentioned before. Now, the placement of the monitors is interesting. I showed Borger Station is located obviously where the name is, and we put 4 monitors around. It would have been nice to have maybe one directly south, one directly north, and one directly north east, which is up to the right. But that area was no homes. That's Ellis Hollow Nature Preserve. Ellis Hollow is the local community within Ithaca that this is in. And also the property on the other side of Ellis Hollow Creek Road there was part of Borger Station. So this is really all we could do to go around it. And what we placed one AirVis, which is the one that measures VOCs, and we placed 4 Purple Air PM 2.5 monitors at all 4 of those locations: Tompkins 1, 2, 3, and 4. And we could, and like I said, we couldn't do any better placement than that. And I noticed that Tompkins 3 at this is one slide or whatever you want to call it, that I actually put the name Borger Station in there myself, and I just at that time Tompkins 3 was offline, but it was not during the actual data collection time. But anyway, you can see the locations of the monitors around the plant. And my home is at Tompkins 1, and the distance from that 0 in Tompkins 1 down to Borger Station is about 1,000 feet. About, what is that, a quarter or fifth of a mile or so. Very close, quite close. So you can get an idea of how close we were to the station. We didn't have a full year of VOC monitoring because the VOC monitor didn't begin until November 1st of 2020. And so we weren't able to have a full year. So the period was chosen as November 20th through March of 2020, November 2020 to March of 21. The winter months, ideally we wanted to do a full year before the project and a full year after the project. We were only able to do that with the PM 2.5, but because this came late. And so what I decided to do was to limit it to the winter months. In the winter months, there's a whole heck of a lot more gas being pumped through those compressors than at any other time during the year. So this is like a worst case. So I took the November to March in 2020 to 2021, and I took November to March in 2022 to 23 to look at the improvements. Weather data, when the wind was coming from the facility, wind speed and direction, was collected with the data shown above. And comparing the 2 above periods, even though the baseline concentration increased from 77.3 to 93.3 over on the left. When the directionality of the wind, that's the beauty of this system. When the directionality is considered, then we're just looking at what the plant is sending us, because the plant is directly south, as you saw in the other previous slide. It's directly south west, southeast. I'm sorry, southeast of the monitors at my home anyway. For the VOC, I had the only VOC monitor. So for that VOC monitor, it was the only one. Okay, and then let's see. Also can be seen in this image. Oh well, no, this is the previous image. This one, yes. Also can be seen in this image is there was a 62.9% reduction in the average concentration above baseline, and the peaks per day were roughly the same, but still quite low. And the average peak duration was reduced by 63.7%. Average time between peaks did decrease slightly, but only by 0.07%. So that basically was very, very close. So these things are important. The peaks and the duration and the time between them are important to know just the seriousness of being out in the air at that time, during those times. These look a little strange to start with, but they really, really are super helpful. North is up. It's like a polar diagram, okay? But north is up, and of course east, right, and west and south are as you would expect. But what's unusual about these is the distance from the center represents the wind speed, concentric circles at the wind speed of 10 miles per hour, 15, 20, 25, 30. So obviously when the wind is high coming from the bottom right, which would be from the plant, the before on the plant coming from the bottom light, would be would definitely be from that plant. And the after, notice how clear it is. However, there was one other thing that I made a mistake on, and that was that this other graph, the mean, the readings on the left graph go to 450. The readings on the right graph go to 250. So really, if I'd done the 450 scale here, which I mistakenly didn't do, then all these things would be lighter. And notice the pollution now coming from the south-southwest. We'll get to that after. Next slide, please. Okay, so these graphs you've already seen, and I like graphs because they visualize what's happening. And in this case, these VOC graphs are visualizing the change in the PM2.5 particulates, and the height, duration, and frequency are important as was shown or mentioned before. Although it may not appear to be a dramatic change, it did improve. So next slide, please. This is the last full year. Okay, this is the last full year of PM 2.5 when from full year of data, and as can be seen here, there are an overall reduction of 31.3% in the 98th percentile of 24-hour readings, and 24% overall reduction in the average of all readings. When compared to the EPA standards, all Tompkins County readings and to all Airview readings, we're doing very well in the community at Ellis Hollow. And so I have a couple other things. I don't know if I have time, but my additional point is that if we go back to that slide where it shows the after on the VOCs, before that one more back, it turns out that this one on the right, that air pollution, I took a map from Google and I drew a straight line in the south-southeast direction, and it was all homes, but 1 mile out, there was the connection of the gas line that produces all the gas, that brings all the gas to Cornell University for heating their campus. And it showed that that's the only thing that was along that line that could have done this pollution. And I contacted the person at Cornell, and they didn't, and I finally got to the right person, and they couldn't believe that I found that. And they said that, but it wasn't something they didn't know about, because they had just been working on it. And they said, take a new reading and see what you get. Did a new reading, and it was clean. So I just thought that was an interesting thing that happened during this project. That's it.
That's great, Stu. Thank you so much for the presentation. We have a couple questions in the chat. Could you please explain the limitations of the National Ambient Air Quality Standards and the impacts of the spikes in emissions from the facilities?
I think Nathan would be better for that,
Okay.
actually. Sorry, Nathan.
Can we bring Nathan up?
Yeah. So the National Ambient Air Quality Standards are great tools and have really led to incredible reductions in pollution in communities across the country since they were enacted by the Clean Air Act. That being said, they do look at, in their shortest time duration, daily pollution levels of criteria pollutants. And what that means is that you can have short-term spikes in pollution that don't necessarily push an area over the National Ambient Air Quality Standard, but can have real impact on the folks that live near it, that can have those short-term health impacts that I was discussing earlier, right? Things like asthma attacks, things like irritation, headaches, and we also have studies that show increases in hospitalizations due to heart attacks or COPD that happen on a shorter time scale than the 24-hour average that the National Ambient Air Quality Standards are looking at. I hope that answers your question.
Thanks, Nathan. Stu, could you talk a little bit about the process of simplifying complex data for your neighbors and community members? What was the most maybe difficult piece of that, or something that really stuck well with other members of the community?
I would say that just showing them a bunch of numbers is not enough. I think you have to tie it in, of course, with what these pollutants can do, and then show that the levels are dangerous. And I happen to like graphs, visualizing it rather than just a bunch of numbers, because people's eyes get blurred over when they see all those numbers and say, oh, well, what am I doing here? So I just think if it can be shown, like the darkness of that in those two graphs, it was the special, like the one coming, the before for the compressor station, and the after that was coming from the Cornell connection to the pipeline, was, to me, you get a feel for how bad it is. And then, of course, if you look at the numbers, you start looking at the numbers, and you know that it's serious. So I like using graphs and images to show it. I think it's wonderful, and I think in particular, Nathan's done a super job with managing the data and making it easily accessible to people once you understand it. And I'm just very pleased with how it all worked out.
Oh, that's wonderful to hear, Stu. Thank you so much. And we really appreciate you sharing your experience with all of us today. We're certainly always grateful for opportunities to hear about what community projects look like in practice.